Oh, it'll be fine. It's not that fun.
How y'all doing today?
Funny. Okay. Look, okay, listen. 32 contains a concept that is not new, but it, we need to talk about it some more. And one way you get prepared for this test is to recognize when two different problems in a packet actually are testing you on the same concept. Once you can start to see that, you're on your way. Because now you're not looking at the problem. You're noticing, wait a minute, this problem looks very different, but it uses the same concept. So for example, just so you can start to learn how to do this, 32, 26, 20, and 23. So this one, 23, 26, and 32, they all use the same concept. They're all presented quite differently, but they all use the same concept. So don't, in this class, say things like, oh yeah, I need to know about that one with the tables. I'm like, there's tables everywhere. That doesn't tell me anything. But anyway, here we go. It says the function f is continuous. That clue that a function is continuous, I use that about 25% of the time. The other 75% of the time, I don't really need it. So kind of keep that in mind. Twice differentiable is a similar clue. Sometimes it is essential. Many times, not so much. So I've kind of learned to just remember those, but not worry too much yet. Keep going. The interval, keep going. This one I'm going to stop on. So this one, if you don't know the two meanings of that, I would immediately pick up a flashcard. And on the flashcard, I would write f prime of 3 equals 2, and then a question mark. Because the idea of the flashcards is, this is not a fill-in-the-blank type test, where you read the questions and your mind can oh yeah, that's the definition, you just fill it in. You have to from thin air remember things. So the front of your flashcard shouldn't say a whole lot. It should just be like, hey, when you see that on the test, what should you be remembering? Then when you flip it over, it should say number 1. On the graph of f at x equals 3, the tangent slope or derivative or instantaneous rate of change of f is 2. That's what you have to remember. Writing out instantaneous rate of change is kind of lengthy, so don't use this on the AP test, but in your notes, this is a nice, convenient abbreviation. So, not to be confused with the DRU thing. Instantaneous rate of change.
That's what it equals first?
So I'll say it one more time. So this is going to be on one side of your flashcard, question mark. On the other side, it's going to say, number 1, at x equal 3, on the graph of f, it's 3 different things. The tangent slope, comma, derivative, comma, instantaneous rate of change of f is 2. That's what it should say on the back of your flashcard. Item 1, there's an item 2 still.
Tangent slope, derivative.
So it's tangent slope, derivative, and instantaneous rate of change of f. Okay, a habit everyone needs to develop. If you listen closely when I speak, you'll notice I have the habit. You need it as well. Whenever I'm talking, I say over and over again, f, f prime, f double prime. So here I'm saying, what does this mean? On the graph of f, at x equal 3, the derivative of f, or tangent slope of f, or instantaneous rate of change of f would be 2. That's the first meaning. Other questions about that? Again, as Mariel said, make sure you understand, then flashcard, then memory. So, please, Danny.
Just to review, the tangent slope is like at the top of the hill when it's flat.
Not quite. Good question. So the idea is that the graph of f could have any shape. Tangent slope is simply the slope of the graph at any point. So I could find a tangent here, and whatever the slope of that line is, that's exactly the same as how fast f is changing at that moment. Does that make sense?
Thank you.
2 points. You know, please.
So when it says twice differentiable, does that mean that the graph of f has the f prime and f double prime? That's all it means?
That's all.
But it doesn't go to f triple prime.
Not for, if f is twice differentiable, all you know is that you can successfully find every tangent slope of f, and you can also then take the graph of f prime and find every tangent slope of f prime. That's it, twice differentiable. There you go. Okay, item 2 on the same card should say, so you say, you know, the front says, what does this mean? The back is the meaning I just gave you. Item 2 would be, oh, on the graph of f prime at x equal 3, the y-coordinate is 2. I've been telling every class period that I know that you have sat in other math classes. And when the teacher says things like, hey, here's one way to do it, and here's another, most people just check out on the other. They just say, one's good enough for me, I'll just learn one way, I'm happy. That doesn't work in this class. The test writers will test you on both ideas. So you have to know both meanings. Question? Please. Say it again.
Can you explain the second one a little bit more?
So the second one is simply referring to the graph of f prime. And it's telling you that on the graph of f prime, or the table for f prime, or whatever, that when the y-coordinate is, sorry, the x-coordinate is 3, the y-coordinate will be 2. That's all. 2 points for Bree. Does that answer your question, Bree? There we go. Okay, y'all need another flashcard. Now, when I tell you to have a flashcard, it's your choice. If I'm saying something that you're like, I don't have any trouble remembering that, it's fine. You don't have to make one. If you have a different system for memorizing, you don't have to use the flashcards. I am very much against compulsion. Like, I believe that you should have your freedom to choose. So, both the choice and the consequences, of course. They go together. Can't have one without the other. So, feels like Sunday. Okay. I was on the video and everything. Great. All right. Incriminating evidence. All right. Listen. Hadley asked about differentiable. That will be tested. So I would have a flashcard that on one side it simply says differentiable. The question mark.
Isn't there a big difference between saying this graph is twice differentiable and then this is the f prime prime graph?
Yes, let me say that back to you, Harrison. Point. If they say, you know, the following function is twice differentiable, like, or they say the function f, 1 second, I'm sorry. If they say the function f is twice differentiable, they're talking about f. They're just telling you that from f you can derive f prime and f double prime. If they say the following is the second derivative of f, now they're giving you f double prime. Is that what you meant?
Yeah.
Adam, please.
So I was just confused about what differentiable means. Is it the same thing as continuous? Is it continuous on the graph of the derivative?
No, so let me keep talking about that. It's kind of that, so let's keep talking. 2 points for Adam. So you can have a flashcard that says differentiable, question mark. When you flip it over, it's going to say this. F is differentiable if I can find the tangent slope, comma, derivative, comma, instantaneous rate of change, same phrasing, of F at every point on F. So F is differentiable. So look up 1 second. So there's a pattern here to help you memorize more easily. Those three things always go together. Tangent slope, derivative, instantaneous rate of change. So the phrase is, F is differentiable if I can find on F the tangent slope, derivative, or instantaneous rate of change of F at every point. That's what makes F differentiable at every point of F. So that definition is all about F. Okay? F is differentiable if I can find the tangent slope, instantaneous rate of change of F, or derivative of F at every point on F. That's what makes F differentiable. Related to what Adam said, there's another point from him. Okay, now look, the two cards tie together. You need to see how they tie together. Well, the y-coordinates of F prime are the tangent slopes of F. So item 2 on my card would say F is differentiable if I can find every y-coordinate for F prime. F is differentiable if I can find every y-coordinate for F prime. Because the y-coordinates of F prime are the tangent slopes of F. The ideas connect. Questions?
Every what coordinate?
Every y-coordinate on F prime. In all of our discussions, we are almost always referring to y-coordinates. The x-coordinates are almost always used simply to locate where we are talking about. So we're talking about like the y-coordinate of F, and the y-coordinate of F prime. Danica's chart is all about y-coordinates. Right? Item 3 on your card should say undifferentiable. Get some tape out and you have to. F is not differentiable if F has a discontinuity, corner, or vertical tangent. And these aren't new, we're just getting them on your flashcards. So F is not differentiable if F has a discontinuity, corner, or vertical tangent.
So when F is non-differentiable, what will that look like on the velocity or acceleration graph?
So we want to be a little careful with that. We could think of velocity as being F. So don't always think that velocity is F prime, but it's okay. Easier to just say, what will F prime look like?
Yeah.
Okay, everybody can get a point for this. To answer Harrison's question. He said, if F has a, what did you say, if F is non-differentiable? If F is not differentiable at some point, what do you expect to see on the graph of F prime at that point? Show me your hand. This is a really good test of your understanding of the concept. If F is not differentiable at some point, what do you expect to see at that point on F prime? Let's go, Ray. Dang! Said it with such confidence and everything. Shin.
Isn't it if it has a discontinuity, like a jump, movable, anything like that, or a corner?
It's actually simpler than that. So not quite, not quite. So if F is, okay, again, listen close. You got to say the right words. If F is not differentiable at some point, what will you expect to see on F prime at that point? Connor? Say it again. Nothing. It's worse. There's nothing there. It is a discontinuity. It's a type of discontinuity. But most important, in my opinion, is you just don't see anything. Because the y-coordinates of F prime are the tangent slopes of F. And if F has a if f has a,
Non-measurable.
if if the slope of f can't be measured, because f is not differentiable, I have nothing to write down for the y coordinate on f prime. How many knew it before he said it? 0.2 for Connor. Question? Answer your question, Harrison.
Yeah.
Good. Okay, I can answer Adam's earlier. Everybody can answer this. Yeah, simple definition of continuity. Don't make a card yet, just understand this. A simple definition of continuity is you look at the graph and you see all the points. And there's no jumps, like they don't go from here to here. And there's no vertical asymptotes where there would be a point missing. And there's no removable where there'd be a missing point. They're just all there. And they're all connected. Okay? So, if f is differentiable, does that, that's too hard a question, never mind. It doesn't guarantee that f prime is continuous. Because just because I can find the slope everywhere on f, doesn't mean that I'll end up with a continuous f prime. So don't think that. There's an example right here. We did one this morning. It's actually in the video. I didn't erase it. Somebody asked for what would this graph look like if we were graphing f prime right here. So here was f. And they said, what would the graph of f prime look like? Over here on the graph of f, each and every one of these tangent slopes is the same. So there's no numbers, but we just said, well, let's just say the slope is always 2. And then on this side, let's say the slope is always -2. So when I plot those y coordinates as a graph of f prime, I end up with a whole bunch of dots at y = 2. I have no dot, like Connor said, there's another point, at x equals c, x equals c, and then I have a bunch of dots at y = -2. So, oh, but I said that wrong. So I'm confusing myself now. This is where f is not differentiable. So if f is differentiable, I'm not sure I have to think about that one. So, other questions? Please.
So if there's a corner on the graph of f, I mean f is continuous, but f prime is not.
So in that example, f was continuous, but the corner on f made f not differentiable at that point. Not necessarily f prime. Although once f is not differentiable, because there'll now be a missing point on f prime will also be not differentiable. Point. Okay, back to here. Any other questions? Look, the whole idea again is to get the concepts, not the problem. Questions to here? So we know the two meanings of this. This clue here I would never ignore. I've never seen an AP problem where they give a clue similar to that where it's not been essential. So someone, actually all who know, raise your hand and tell me, what is that clue telling you? What is that clue telling you? Let's go, Eli.
It means f double prime is going to be negative.
Which leads you to know
That f prime is decreasing and f is concave down.
how many knew it before he said it? 0.2 for Eli. Okay. Any questions on that? Okay, so keep reading. Which of the following could be the table for f? Okay, here is the concept that is being tested on problem 32, problem 26, problem 20, and I forgot the other one. 23, I think.
Yes.
Here's the concept that is being tested. The word concave down means the following. If you have a graph that is concave down, so here's an example of concave down. Okay? Memorize the following. So first, understand the following, then flashcard it, then memorize it. As you read this graph from left to right, Just say it out loud, please. How many points are there?
A lot.
Good enough? Lot, infinite, whatever. Okay, how many tangent slopes are there?
A lot.
A lot. Okay. As you read the graph from left to right, and you pay attention to tangent slopes. So I look at this tangent slope, and then maybe I compare it to, say, this tangent slope, and then maybe this one, and maybe this one. If the graph is concave down, so this is F, if F is concave down, then as you read the graph from left to right and you pay attention to the values of the tangent slopes, those values must decrease. You have to understand that. If the graph is concave down, the graph of F, you read the graph from left to right, and you look at the values of these slopes, those values must decrease. It's not the line that's decreasing. Look, this slope, this tangent line is pointed upward. That's not what I'm talking about. I'm talking about the value of this slope compared to the value of this slope. This slope is some positive number. I don't know, 9. Raise your hand if you know the following. Is the value of this slope going to be, just raise your hand if you know, greater or less than 9? Just look at it and think in a common sense way. Don't try to math it, just common sense it. Okay, well, less. This line is definitely steeper than this one. So if this slope is 9, this is maybe 6. I don't really know, but how many knew it before she said it? Point 2 for Nicolette. Please.
I understand that on like the left side when the line is going up, but once it starts going back down, the slopes are still decreasing.
Yeah, here's why, Marielle. The slope over here is negative, maybe -5, as I compare it over here to this +6. So as you read from left to right, and we look at the slope values, they decrease. 9, 6, -5, -8. Does that answer your question? 2 points. Okay, that's the concept. You will be tested on that concept at least 3 times on this test. One next Thursday. Okay? So when a curve is concave down, when a function is concave down, I just look at the D right here. It reminds me. Oh yeah, that means if I read left to right, I will see that every single slope that I measure, I see a decreasing pattern as I measure those slopes. The same is true if you're looking at secant slopes. So if I'm going to find the slope from here and jump clear to here, okay, raise your hand if you can answer this question. Again, don't math it, just common sense it. Strange verbs, but whatever. You've got this green slope of 9. You've got this purple slope. Just raise your hand if you know which is less, the green or the purple. Don't math it, common sense it. Which is less, Cole? How many agree? Point, 2 for Cole. Okay, that matches the idea of concave down. As I read the graph from left to right, and I measure slopes, it doesn't matter if I measure tangents or secants, there must be a decreasing pattern. So the tangent here, followed by the secant that went clear to here, that must be a decreasing pattern. Answer this one. Look at the red slope up here of 6. Compare that to the purple slope. Raise your hand if you can tell me which one is least. So the red and the purple. Let's go, Hannah, sorry. How many agree that it is the red one that is least? Point, 2 for Hannah. It's the same concept again.
That also means that each secant slope consecutively will be less, right?
Absolutely. We have this that's 2 for Matthew. Answer this. Okay, I have simply declared the green slope to be 9, so we have something to talk about. And the red slope to be 6. But if those are both, if that's true, if this is really 9 and this is really 6, I know exactly what this, well, I don't know exactly what this has to be, but I know where it has to fit. I usually have to know what the heck I'm talking about. Like, I know the value of the purple slope, kinda. I don't know it exactly, but I can kind of narrow it down. Who knows what I'm talking about? What's the value of the purple slope? Just at least kind of narrowed down. What's the value of the purple slope, Matt?
This is 3. No.
2 points, but no, it's no worries. What's the value of the purple slope? Tyler,
Somewhere between 9 and 6.
how many knew that? 2 points.
Could you use Pythagorean's theorem for that?
No. I suppose in some cases maybe, but I don't know of any general rule where that would work.
Because I'm just like, it kind of makes a triangle like the lines.
I get what you're saying. It's not a right triangle rule.
Oh, yeah.
Hey, question. Okay, that's what concave down means. As you read the graph from left to right, must be a decreasing pattern. Any questions on understanding that? Now, you had a different question. You said...
I said each secant slope.
Oh, right, yeah. Same thing. So if I go here, let's do a different color. I'm running out of orange or. Who knows what slope the orange must fit between? Like what slopes must the orange fit within? Let's go, come in.
6 and negative 5.
6 and negative 5. How many knew it? 0.2 per minute. Okay, cool. Question. Awesome. Go back to this one now. So that's the concept. Now we're going to answer this problem. So you tell us all this. They said which table is, which is the right table. Honestly, the first time I did this problem, I didn't have a clue what the heck they were even asking. Welcome to the AP test. Very normal. But I have learned to not worry about the fact that I don't know what to do. I just find a clue, then I try something. So what I did was, this means tangent slope of f is 2. Also means y-coordinate of f prime is 2. Points for the whole room. Based on what they're giving you, which of those two definitions would you think is more important for this problem? The fact that this is telling us the tangent slope of f, or would you think it's more important that they're telling you the y-coordinate on f prime? So pick one of them and give me a reason why you picked it. This is a good example of demonstrating how you think your way through a problem you don't know what to do. It's okay.
I choose F double prime because it gives you more of a broad range, I guess.
Keep talking. What you mean?
So like for F prime, it's only giving you one coordinate.
Oh, I meant so. You're 2 points. You're answering a different question. I apologize. No, you're doing just fine. You were looking here, and you are 100% correct. This clue is. I know that one's significant. Yeah, so I'm good there.
Wait, what's your question?
Sorry, no worries. This has 2 meanings. It's telling you that on the graph of f prime, the y-coordinate at x equal 3 is 2. But it's also telling me that on the graph of f, that the tangent slope at x equal 3 is 2. So for this definition, is it better that I think of the f part of that or the f prime part of it? That's what. Does that make sense, Kate?
Yeah.
So which part, Jacob?
I think it's better to think of the tangent slope on f because it's giving you the list of coordinates for f.
Let me agree with Jacob. Yeah, 2 for Jacob. It's exactly the right. Now listen, hey, the most important part of his answer is his reason. They're giving you all of these tables of f. So that leads me to think, hey, they're really talking about the tangent slope of f. And to be honest, even though this has 2 meanings, which you do need to remember both, most of the time they are referring to the tangent slope of f. Okay? Questions? You need another flashcard. I would make a flashcard with a really simple table, like this is great. Just put this on my flashcard on one side. Super simple table. And then I do the traditional big old question mark next to my table. So I know that this is the card I look at and go, what am I supposed to be remembering when I see a table?
Like with numbers or just?
I put in some numbers. You don't have to, it's up to you, whatever.
Is this the selected values card?
Part. So if you have one that has that, we're gonna build on that. Maybe you might have all of it already. Because I'll be honest, I have never found the time to like make my own flashcard deck. Like I see something like, oh yeah, you guys need to remember this. But then I spend so much time helping after school and stuff, I'm like, I just ran out of time to make it anymore. So I don't even know what the heck that flashcard is, but we're gonna say it, I think. So got the table on one side, right? On the other side, it should say, the order here doesn't matter, but 1, tables only show selected values. You do get tested on that regularly. Don't make assumptions about what's happening between what you see. That's the key to solving problems. There's one in this packet that's the key. To recognize that you don't know what's happening in between. So don't assume. So tables only show selected values. What else did we have you put on that one, Gil? We did this morning, right?
Yeah. If I can find it. Oh, perfect. You can't find a tangent slope from the tables.
Can't find a tangent slope from a table. Can't find a tangent slope from a table. But you can find a secant slope from a table. That it? Cool. Question. So the third one is, but you can find a secant slope from a table. Just let everyone finish writing. Okay, so this is where everything gets tied together that we've been talking about. They're telling us that the tangent slope of f at x equals 3 has a value of 2. We have all these tables, but we can't identify which of these functions of f has a tangent slope at x equals 3 of 2. You can't do it. So instead, we go find the secant slopes of these tables. Secant slope is easy. It's just change in y divided by change in x. So over here, we're going to find the change in x. Here, we're going to find the change in y. So the change in x is easy. Don't assume that change is always 1. It isn't. In this case, it is. Please.
Doesn't the f prime 3 mean that between 2 and 3 there's going to be an increase of double?
This means that at precisely x equals 3, the y-coordinate is increasing at a rate of 2 at that exact instant. That's hard to comprehend in my opinion. That doesn't necessarily mean that we're going to go up by 2. It just means that that instant you would if the rate remained constant. But the rate doesn't necessarily remain constant. So this is getting complicated, but no. So. Questions on the secant slope 2 for Harrison? Okay. Raise your hand if you know. Does this indicate a curve that is concave down as required by the other clue? Hands up, you know. Come on. Does that indicate a curve that is concave down, which was a requirement of the clue here? Emma?
Yeah.
How many vote with Emma? What's the reason, Emma? Secant slope is decreasing. 2 points, 1 for the rest. Question? Okay. So that fits this clue. We need to see if it fits this clue. Well, at x equals 3, the tangent slope of f is supposed to be 2. So if you picture this thing, increasing concave down, we know that the secant slope from here to here has a value of 2.5. The secant slope from here to here has a value of 1.5. The tangent slope here is supposed to equal 2. Raise your hand if you feel like that fits every clue that's possible or doesn't fit every clue that's given. Hands up. So somebody explain, let's see, let's pick on Dan this time.
Does.
And why?
Does 2.5 and 1.5, 2 is right in the middle.
Works perfectly. We're supposed to have a function f that is concave down. This f is concave down because as we read the slopes from left to right, we have a secant slope of 2.5, tangent slope of 2, secant slope of 1.5. Again, make sure you are paying attention to the details. Don't just memorize, well, as long as the numbers do this, I'm good. Doesn't mean anything. They will fool you for sure. Like, memorize the whole concept. 2 for Dan, 1 for the rest. Question? Awesome. If you check the rest of them, you'll find that this pattern does not hold. For example, if I go here, I get a secant slope of 2.5, followed by a secant slope of 2. But the tangent right in the middle is supposed to be 2. So as I read the graph from left to right, I'm seeing a secant of 2.5, tangent of 2, back to secant of 2. That doesn't work. The slopes are not decreasing. Question? Anything else on this problem? That was a really good problem to discuss. 3 major flashcards. Came 3, right?
Yeah.
Came from that. It's very good. Yeah, please.
I have a question on the concave down.
Please.
So would the secant slope between 9 and 6 be the tangent slope of 7.5?
Not necessarily.
Okay.
No, there's no rule that indicates exactly where it fits. So that's, you wouldn't want to memorize that. Good question. Good point. Okay, next one. Stop this video, start another one.